Okay, now let us discuss about the new topic open circuit impedance parameters. Actually, impedance parameters are represented using Z, and you might have a doubt regarding the term open circuit. Why the name open circuit here? It's because the impedance parameters can be found only making the circuit as open circuit. That's why the name open circuit impedance parameters. And now let me say about the parameters. Before that, let us draw the basic block schematic diagram for the two-port network, and I will be back to you after that. Okay, right? This is a basic block schematic of two-port network. Here 1 dash is the input port, and the current flowing into the network is I1, that is the input current is I1, and the voltage across the input terminal, that is V1, and that across the output terminal to 2 dash, it is V2, and the output current is I2. This is the basic block schematic, and now let us define the open circuit impedance parameter by its basic equation. V1 is equal to Z11 I1 plus Z12 I2, and the next equation is about the output equation. This is regarding the input section V1. Okay, V1 is a function of input impedance and the transverse impedance. Now let us try. Let us try to understand this much only. Okay, right? Now let us write the output equation. V2 is equal to Z21 I1 plus Z22 I2. Okay, this is equation number 1, and the another one is equation number 2. Okay, simply speaking, the open circuit impedance parameters are represented by these equations 1 and 2. We will have to by head this equation only, and in matrix form let us write it as V is equal to Z into I. Okay, now let us write this, let us replace this voltages, impedance parameters and currents as V1 V2, that is regarding the input equations for the voltages. Okay, for the input voltage and output voltage section, that is of the form of a column matrix. Okay, right? Now this is Z parameters. So they are of 4 types: Z11, Z12, Z21, and Z22. So now let us express this as a square matrix having 2 rows and 2 columns. Z11, Z12, and the next one is Z21, and the last one is Z22. Okay, right? Now we have 2 currents, I1, that is input current, and I2 is output current as well. Of course, we had to express in the form of a column matrix. Okay, I1 and I2. This is the matrix representation for open circuit impedance parameters. Otherwise, this is the matrix representation for equations 1 and 2. Now let us find the expressions for these impedance parameters: Z11, Z12, Z22, and Z21. These 4 parameters are known as the open circuit impedance parameters. Okay, right? Now let us try to find these. Let us try to find the expression for all these parameters separately. Okay, right? First of all, let us try to make the output current equal to 0. Output current in the sense in the circuit, this I2 should be 0. How can we do that? We all of us know that the current is 0 only if it is open circuit. In a closed circuit, there should be a current. There should be a current flowing through a closed circuit. But in the case of an open circuit, there will not be, there won't be any current. Therefore, In order to make I2 0, we have to open circuit the output port. In order to make the current I1 equal to 0, we have to open circuit the input port. That's why the name open circuit. Now you can understand that. Why the name open circuit? The current will be 0 only if it is in open circuit stage. Okay, right. So now let us try to make the output current I2 equal to 0. How can we do that? Just left this output port as open circuit. Okay. Now consider the situation I2 is equal to 0. That is, if only if the output port 2 dash, okay, 2 dash is open circuited. Here it is left open circuit. Now I2 will be 0. So in equation 1 and 2, now let us substitute for I2 equal to 0. Okay. Okay, I2 equal to 0 in equation 1 and 2. If I2 equal to 0 in equation 1, here this quantity will vanish. The second term will vanish, and the only term remaining in the left hand side is V1. So we may write is equal to V1 is equal to Z11 I1. Okay, right. Z11 I1 plus Z12 into I2. What about I2? That is equal to 0. So this one will be 0. Now we can find the expression for we can find here we have only Z11 I1. Okay. From this equation, now let us find the expression for Z11, that is equal to V1 divided by I1. What about this one? What is V1? That is the voltage across the input port. And what about this current I1? That is the input current. So simply speaking, Z11 is the ratio between input voltage and input current. Okay, right? That is known as input impedance. Simply V by I is the voltage to current ratio. That is known as the resistance. Okay. Resistance in an AC circuit is known as impedance. Okay. So V by I ratio is actually impedance, as V1 is the input voltage and I1 is the input current. Input voltage by input current gives the input impedance. So let us define Z11 as the open circuit input impedance. Okay, right? This is under I2 equal to 0 is known as open circuit. OC stands for open circuit input impedance. Similarly, in equation 2, if we substitute for I2 is equal to 0, we will get the another impedance parameters. Now we go to the expression for one impedance parameter Z11. Okay, right? Now let us put I2 is equal to 0 in equation 2. Okay, this is equation 2. Now I2 equal to 0 here. So the terms remaining will be V2 equal to Z21 I1. Okay, right? Z21 I1. Then plus, what about the second term of second equation? Z22 into I2. I2 is equal to 0 here. So this one will be 0. Okay, now what we obtained is V2 is equal to Z21 I1. From this, we can find the expression for Z21, that is equal to V2 by I1. What about this term V2? That is the expression for output voltage. Okay. What about I1? That is the input current. Okay. Output voltage by input current. Okay. Simply voltage by current is known as impedance. Okay. Here it is regarding output port and I1 represents input port. So output by input. So there will exist a transfer ratio as both these terms are not belonging to the same port. This V2 belongs to output port and I1 belongs to input port. So this is a transfer ratio. Basically, this is voltage by current ratio, but this is a transfer ratio. So let us call this as open circuit forward transfer impedance ratio. Okay. So now we could obtain the second Z parameters, Z parameter Z21, that is equal to V2 by I1, known as open circuit forward transfer impedance. Okay, now we have to find two more parameters, which are them, that is Z12 and the another one is Z22. Okay, right. For that purpose, we have to make the input current equal to 0. I1, if we set I1 is equal to 0 in both equations 1 and 2, we can obtain the expression for Z12 and Z22. Okay, right. Now let us see that. Okay. Then how can we obtain I1 is equal to 0? As we already told that the current will be 0 only if it is open circuited. So now let us open circuit the input port. So I1 will be 0. Okay, right. Port 11 dash is open circuited, then we can say that I1 will be 0. Okay. So in equations 1 and 2, if we substitute I1 equal to 0, what will be? In equation 1, if we substitute for I1 is equal to 0, the remaining term will be V1 equal to Z1 to I2. Okay, right. Now let us find each of them, okay, separately. In equation 1, if I1 is equal to 0, the terms remaining are V1 is equal to V1 is equal to, the first term will vanish as I1 is equal to 0. Okay, 0 plus what about the second term, that is Z1 to I2. Okay, right. Z1 to I2. Okay, that is V1 is equal to Z1 to I2, and from this we are obtaining Z1 is equal to V1 by I1. No, sorry, V1 by I2. Now again take a look. This is the ratio between voltage and current. V by I is simply the impedance, but V1 belongs to the input section. V1 is the input voltage, and the I2 belongs to the output section. I2 is the output voltage. Input by output ratio. Again, this is known as transfer ratio, as in the earlier case. Just we have discussed here. Okay, V2 by I1, that is a transfer ratio. As this term belongs to different ports 2 and 1. Here also these terms belongs to different ports, port 1 and 2. So this is basically this is V by I ratio. So this should be, of course, the impedance ratio itself, but both belongs to different ports. So this is a transfer impedance. So now let us call it as open circuit reverse transfer impedance. Okay, right. V by I. Okay, this is reverse transfer impedance. Now in equation 2, if we substitute for I1 is equal to 0, the remaining terms will be V2 equal to 0 plus Z2 to I2. Okay, now let us do that. In equation 2, if I1 is equal to 0, V2 is equal to V2 is equal to, the first term will vanish as I1 is equal to 0. So that will be 0 plus the second time is Z2 to I2. Okay, Z2 to I2, that is V2 is equal to Z2 into I2. Hence, Z22 will be V2 by I2. Again, here it is a voltage to current ratio. So, of course, that should be an impedance parameters. Then, what about V2 and I2? Both belongs to the same port. That is, both belongs to the output port. V2 is the output voltage and I2 is the output current. Okay, right? So, Z22 is simply the ratio between output voltage to output current. So this is basically known as output impedance. Okay, right. So specifically we can call it as open circuit output impedance parameter. Okay, right. So now let us recall what we have discussed. The first parameter what we obtained is Z11, that is equal to V1 by I1 only if I2 is equal to 0. V1 by I1 at I2 is equal to 0, and Z21. Okay, Z21 is equal to V2 by I1. V2 by I1 under the same condition, that is I2 is equal to 0. Then we got the expression for Z12 under I1 is equal to 0. Okay, right. Z12 is equal to V1 by I2 under I1 is equal to 0. And finally, we got the expression for Z22 under the same condition I1 is equal to 0. This Z22 is equal to V2 by I2 under I1 is equal to 0. Okay, these are the 4 open circuit impedance parameters. Okay, thank you.